Hi, this is Professor Salazar, and today we're going to talk about subnetting, and I'm going to show you how you can subnet IP addresses. And before we get started, I just want to talk about um, subnetting in general usually requires it requires the user to know how to translate binary to decimal or decimal to binary. So if we understand that conversion of decimal to binary, then we can learn how to subnet. So the first thing I'm going to do is I'm going to share my screen. I'll be using Microsoft Excel just to display some results in a chart, and we can start learning how to translate binary to decimal. And from there, we can start learning how you can subnet IP addresses. So let me go ahead and get started by sharing my screen. And if you're looking at my screen right now, I have a piece of code that I wrote in Python that will automate all of this for me. So let me just go ahead and start by running this code and showing you that if I type in any IP address, like 192.168.1.1/24 for the CIDR notation, it's going to display my results as far as how you can subnet that IP address, where that target IP address lies within a subnet. And here it shows me my subnet mask is 255.255.255.0. My network ID is 192.168.1.0. The first IP address is 192.168.1.1. The last IP address is 192.168.1.254. And the broadcast address is 192.168.1.255. So I'll cover this in a little bit, but I just wanted you to see that I've kind of automated all of this subnetting with the script that I wrote in Python. All right, so let me go into Microsoft Excel and let me show you what you can do as far as learning how to subnet. We first need to learn how to translate decimal over to binary. And I'll show you why this is important in a little bit. But what we can do is make a chart first in order to translate decimal over to binary. So what I'm going to do is start out with a chart that starts with 2 to the 0 power. 2 to the 0 power is going to equal 1. And 2 to the first power equals 2. 2 to the second power equals 4. 2 to the third power equals 8. 2 to the fourth power equals 16. 2 to the fifth power equals 32. 2 to the sixth power equals 64. And 2 to the seventh power equals 128. And I'm going to go ahead and stop there. We can keep on going when we're using base 2. But I'm going to stop there for a reason, is because whenever we're talking about translating from decimal over to binary, what we're really doing is we're using bits of data. These can be representing bits, and 8 of these bits equal 1 byte of data. So for example, whenever you go all the way from 2 to the 0 all the way to 2 to the 7, that could be represented as a byte of data. Okay, so let's say, for example, I want to calculate some type of a number, like maybe I'll just give you an easy number, like 102, for example. Now, how would I calculate 102? Well, according to this chart, I would have to add up these numbers and get the sum of these numbers and have them equal to 102. Okay, so this is a decimal representation of 102, but the binary representation is adding up these bits. Okay, so if I add, for example, 64 to something, like let's say adding 64 to 32 is going to give us 96. Okay. Now, if I add 96 to 16, I may actually go over that, or I may be like right on the dot of what it is. And I'm thinking that I'm going to go over. And you're welcome to use your calculator at this time. But all you have to do is add up the bits. Let's say, for example, you're going to add up 96 to 16. Well, 96 plus 16 equals 112. And you've already gone over your target of 102. So instead of placing a 1 under 16, I'm going to place a 0 under 16. The same thing with 128. 128 is too high. So 64 plus 32 equals 96. 96 plus 8 equals 104. I've already gone too high, so I'm going to have to place a 0. 96 plus 4 equals 100. Therefore, I'm going to place a 1 underneath the 4. And 100 plus 2 equals 102. And we're going to let go of that 1 because 102 plus 1 equals 103. Therefore, we're too high. So as you can see, if I add up 64 plus 32 plus 4 plus 2, that's going to equal 102. So your decimal representation is 102, and your binary representation of 102 is 011001110. Okay, so that's how you can translate a binary number over to a decimal number right there. And these are called bits. These zeros and ones are just bits. 1 representing on, 0 representing off. Okay, let's go ahead and do another number. And I'll do something like 63. So how would I represent 63 as my binary representation? If I wanted to translate 63 over to binary, well, I can't add 128 to anything, and I can't add 64 to anything. So I'll place zeros underneath that. But I can add 32 to something, so I'm going to add a 1 to 32. 32 plus 16 gives me 48, so I'm going to add another 1 to that. 48 plus 8 equals 60. Oh, I'm sorry. 48 plus 8 equals 56. So I'll add a 1 to that. And 56 plus 4 equals 60. And 60 plus 2 equals 62. And 62 plus 1 equals 63. So therefore, the way you can translate 63 is by adding 32 plus 16 plus 8 plus 4 plus 2 plus 1. Your binary representation of 63 is 001111. I'm sorry, let me say that again. Your binary representation of 63 is 00111111. Now, if you notice here, if I want to do a binary representation of the decimal value of 255, then I'm going to have to add up all of these bits. I'm going to have to add 128 to 64 to 32 to 1, or I'm sorry, to 16 to 8 to 4 to 2 to 1. If you add up all of these bits, they equal 255. Now, if you want me to say them all individually, 128 plus 64 equals 192. 192 plus 32 equals 224. 224 plus 16 equals 240. 240 plus 8 equals 248. 248 plus 4 equals 252. 252 plus 2 equals 254. And 254 plus 1 equals 255. Okay? So if you understand this chart, you can learn how to translate decimal over to binary. And likewise, I can go the other way around and translate binary over to decimal. So I'll give you an example of this. If somebody gives you a binary number like 01001100, well, what's the binary representation of this number? or the decimal representation of this binary number, well, we're going to have to add up those bits. So anywhere where I have ones, I'm going to have to add up these values. And I'll go ahead and bold these so you can see them. These are the numbers that we're going to add up based on if the bits are on or off. So 64 plus 8 plus 4 will give us our decimal representation of this binary number. 64 plus 8 is 52, and 52 plus 4 is 56. So 0, 1, 0, 0, 1, 1, 0, 0 equals 56 in decimal. Okay. Now, I'll go ahead and leave that up, and I'll just scroll over to the right-hand side so I can show you subnetting. And again, there's a reason why I did 8 bits, is because whenever you're using or subnetting IP version 4 addresses, well, there are 32 bits of an IP address in an IP version 4 address. Let me go ahead and say that again, just to make sure I said that correctly. An IP version 4 address is considered to be a 32-bit address because 32 bits equals an IP version 4 address. Now, more specifically here, any IP address, and I'll give you an example of one. This is an example of an IP version 4 address right here. Just go ahead and write it out. 192.168.0.1. That's usually like the first IP address that you'll see on a Class C network, okay? Now, 192.168.0.1 usually has something at the end called a CIDR notation or a /24, okay? That /24 is representing how many bits are in this IP address that represent your network address. Your network part of this IP address always stays the same, and your host part of this IP address can change. Okay? Based on an IP version 4 Class C address, like the one we're seeing, your network bits will represent the first 3 octets, meaning 192.168.0. And the last octet, which is 1, is telling me that that last octet can change anywhere from 0 all the way to 255. And in reality, we can never use the first IP address in that range, and we can never use the last one. So the first one would be 0, and the last one would be 255. But 0 is part of my network address, and 255 is part of my broadcast address. So you need to remember that whenever we're subnetting, we can never use the first address and we can never use the last one. That means that of total available IP addresses, I would have 254 addresses available. Okay. Okay, so let me kind of show you this. Whenever you see a /24, all we're doing is adding up all our bits to get our subnet mask. So in this situation, if I want to see my subnet mask address, and let me go ahead and put it here. Subnet mask is going to equal 255.255.255.0. And let me go ahead and explain this real quick. Remember that if I added up all of these 8 bits, they represented 255. Well, if you add up 8 bits 3 different times, you get 24 bits. And that's how your subnet mask is equal to 255.255.255. Because 11111111 is equal to 255. 11111111 is equal to 255. And 11111111 is equal to 255. And 000000000 is equal to 0. Therefore, my subnet mask is 255.255.255. 128.255.0. All of these 8 bits, on these 3 rows, or these 3 rows are equal to 24 bits. So a CIDR notation of 24 bits is going to equal your subnet mask of 255.255.255.0. Okay. Now, what you're really doing is when you're subnetting an IP address, you're really just cutting it in half. Okay. And when you cut things in half, what you're doing is you're increasing your CIDR notation. So instead of 2/24, I would have to add an extra bit at the end. And if you add an extra bit to an IP address, like let's say I have an IP address of, let me do this one, 192.168.0.1/25. Well, now my subnet mask is going to change. Oops. Let me fix that real quick. My subnet mask is going to change, and I'm going to have to add 25 bits instead of 24. So if I look at my bits of which are on or off, I'm going to have to add 25 bits. So here's 8 bits, 1111111, which equals 255. 1111111, which equals another 255. That's already 16 bits. And if I add 24 bits, it's another 8 bits, 1111111, which equals 255. And now I have to add the 25th bit to this IP address, which is 100000000. Let me say that again. 100000000, which equals 128. Now, how does 100000000 equal 128? Well, if I go back to my chart, I'm going to add 128 as our target. All I have to do is add that first bit. And that right here equals 128. So this is how I got 128 right here. So my subnet mask in a /25 is going to equal 255.255.255.128. Okay. Let me give you another example here. Let's say, for example, I needed to subnet my network, and instead of just cutting it in half, I needed to cut it in 4 equal slices, right? Well, the IP addresses total that I get from a /24 is equal to 256. When I cut it in half, those 256 are 128 on each side. When I cut it in 4 equal pieces, now I have 64 IP addresses on each quarter. So now what's happening is if I use 192.168.0.1/26, my CIDR notation changed to /26, and my subnet mask is also going to change. Okay. My subnet mask now requires 26 bits to be turned on. So I'm going to have 1111111, 1111111, 1111111, and 1100000. Okay. So all 8 ones added up equal 255, another 255, another 255. And these first 2 bits that are turned on, all I have to do is add 128 to 64. So if I turn on these first 2 bits and add 5 zeros, I'm sorry, 6 zeros, that should equal 192. Because 128 plus 64 equal 192. So if I come over here and I see that, then that last octet is going to have a 192. So my subnet mask is going to equal 255.255.255.192. Okay. Now, in these different types of IP addresses, if we're talking about having a whole network of 256 addresses, what would be my first network IP address, my last network IP address, or my first network IP, my network IP address, my broadcast IP address, and what would be my first available IP address and my last available IP address? Okay. So let's say that this is the IP address that we're working with, 192.168.0.1/24. Okay. And we're talking about a total of 256 addresses. Your first network address, I'll plug it in here. My network address would be the first IP address in that list, which would be 192.168.0.0. Okay. My first available IP address would be 192.168.0.1. That means that this target IP address that I'm using is my first available IP address on a device, like a computer or a tablet or a smartphone, whatever. Anything that's going to connect to a network is going to have an IP address that needs to communicate with other devices or to the internet. You're going to have an IP address, and it's going to have to be within this range of IP addresses. Okay. Your broadcast address would be 192.168.0.255 because that's the last address that's on the range of IP addresses. And the last available IP address that you can actually use on a computer or tablet or smartphone or any device that needs to connect to the network would use 1 minus the last one. So it would be 192.168.0.254. Okay. So anywhere from addresses 1 to 254 can be used for devices like computers and smartphones and whatnot. Okay. The only addresses that cannot be used are your network address, which is the first address, and the last address, which is 255. Okay. Now, if you're, I'll go ahead and copy these because I'm going to use them over again. Just like that. If you were to cut the network in half, what I said earlier is that on each side, you would have a total of 128 addresses. Now, if you have a total of 128 addresses on each side, well, remember that on side A and side B, you cannot use the first address and you cannot use the last one because those are your network addresses. All right. So I'm going to do this. And let me go ahead and insert a row right here. And I'll call this subnet A. And I'll insert a row right here. And I'll call this subnet B. Okay. And I'll go ahead and change the color of these so you can actually see that my network address on subnet A still stays the same as these over here. But what changes are my broadcasts, my first available, and my last available. So my network address stays the same at 192.168.0.0. But now some of these are actually going to change for subnet B. So let me kind of show you this. If I change my subnet to a /25, remember that I'm cutting the network in half. So 256 available addresses change to 128. Now, my first available will still be 192.168.0.1, but my last available is going to change and my broadcast is going to change. If I were to cut it in half, my subnet B would actually start with 192.168.0.128. And my first available would change to 192.168.0.129. That means that my broadcast address on subnet A, which would be the last address on subnet A, would be 192.168.0.127. And the last available would be one before that, which would be 192.168.0.126. The last available on subnet B would be 192.168.0.254. And the broadcast would be 192.168.0.255. So do you see how we still stayed within those ranges of 0 to 255, but we actually just cut the networks in half? We cut one big network in half. And let me go ahead and type subnet A here, representing that this entire network has 256 addresses total. Okay. Now in a /26, remember that what we're doing is we're cutting it in half again, meaning if we cut it in half once, then we have from 126 addresses to 100, or I'm sorry, from 256 addresses to 128. But if we cut it in fours, which we need to do for a /26, then we're cutting it in 4 equal pieces, meaning that we're going to have a total of 64 addresses available. So I'll type in subnet A right here. I'll do subnet B right here. And I'll have to add subnet C. And I'll add subnet C, or I'm sorry, subnet D. So let me go ahead and copy some of this so I don't have to continue doing this. Okay, so let me go ahead and highlight these in red just to show you that they're now 4 equal subnets. And these are going to have 64 addresses total. So the first network address is going to stay the same, 192.168.0.0. The first available is always going to stay the same, 192.168.0.1. But these are going to change now, because if we go up all the way to 64 addresses, then the broadcast address is going to be 192.168.0.63. The next network address for subnet B will be 192.168.0.64. And if we go up by 64 addresses, the next network address will be 192.168.0.96. And the next network address would be 192. I'm sorry, I might have messed up here. It would be 192.168.0.128. All right. And 192.168.0.1 0.224 for our next address, because they go up in 64s. So 0 to 64, and then 64 to 128, and then 128 to 224. If you were going to go up again a 5th time, you would actually go to another subnet in another network address. But since we're talking about class C right now, and we're talking about this /26, you're going to have 4 equal subnets. Okay. So your last available would be one before the broadcast. So it would be 192.168.0.62. For subnet B, your first available would be one after the network, 192.168.0.65. And your broadcast for subnet B would be one less than the network address of subnet C. So it would be, let me go ahead and make these bigger. Which would be 192.168.0.127. And your last available will be one less than the broadcast, 192.168.0.126. Your first available would be one after the network address for subnet C, 192.168.0.129. Your broadcast will be one less than the network address. Oops, I messed up right here. Let me go ahead and fix this. Your broadcast for network C would be one less than the network address on subnet D, which would be 192.168.0.223. The last available would be one less than the broadcast on subnet C, 192.168.0.222. And for subnet D, which would be our fourth quarter, your first available would be 192.168.0.225. The broadcast would be from the broadcast would be the last address in the entire network, which would be 0255, 192.168.0.255. And the last available would be 192.168.0.254. So do you see how the broadcast and the last available of a /24 network are the same as the last available in broadcast of subnet B and subnet D? The only thing that changes are your CIDR notations, because you're adding extra bits. Okay. So I'm going to do one more, and it's going to be a little bit more difficult, but we're actually going to go down to a /27. Okay. So let me go ahead and make this a little bit more difficult. And let me do something like this. 192.168. 2, or I'm sorry, I'll go ahead and leave it the same. .0 dot 194. Okay. So when we see that 194, we might say to ourselves, well, we don't know what 194 is, because at first we don't even know the notation of it. We don't know where our network, our IP address lies. Where is our target IP address? If we add a CIDR notation of /27, all that means is that I added 27 bits to my network. So my subnet mask is going to be represented this way. Let me go ahead and make this a little bit bigger. My subnet mask is going to be 1111111, which equals 255. 1111111, which equals 255. 1111111, which equals 255. And again, if you add up all of these ones, there's 24 bits that are on. And to add 27 bits would be 1110000. Okay, let me make sure they're correct. If I add 27 bits that are on, what is that last octet going to be? Well, instead of it being 192, now I'm going to have to add up 128 to 64 to 32. And that equals 224. Okay, so I'll go over here and I'll type in 224, and my subnet mask will equal 255.255.255.224. Now we're going to have plenty of more subnets, but here's how you can find your target IP address and what network it actually lies. Let me go ahead and type it again. I believe I had to use 194 here, /27. Okay, so if we're looking for 194, we're first going to have to say to ourselves, how many networks does this actually use? Well, instead of 4 networks that we see on /26, we're actually going to have 8 networks that we see on /27. Because remember, we're cutting it in half every single time. So each of those subnets is going to have to be cut in half every single time. So let me go ahead and do this, and I'm going to have more addresses, but I'm going to have more subnets. I'm going to have subnet A, subnet B, subnet C, subnet D, and I'm also going to have, let me go ahead and just copy this down just to make it easier. I'm also going to have more networks with more addresses. Or should I say, I'm going to have more subnets with less of an address range in each of those subnets. Okay. All I'm doing is just highlighting this little table for you. This is going to be subnet C. This is going to be subnet E. This is going to be subnet F. This is going to be subnet G. This is going to be subnet H. This is going to be subnet I. And I believe I need one more here. Let me see. This is going to be subnet A. Let me go ahead and highlight this for you. You know what? I might not even, I might have added an extra address or subnet. We don't need subnet I. But as you can see, we're going to have, instead of just 4 subnets using /26, we're going to have 8 subnets using /27. Let me go ahead and just fill in these titles to each of these subnets. Oh, I accidentally forgot to type in D for one of them. I think that's why I went over. And I do need another one. So I need subnet H. Okay. So there you go. You could see from A through H, I'm going to have a total of 8 different subnets on a /27. But if you can see over here on a /26 address, I had a total of 4 subnets with 64 addresses each. Now, if I cut them in half and get 8 subnets, that 64 is going to change over to 32 addresses each. Okay. So if I use the 32 addresses that I have on each subnet, my first network address would be 192.168.0.0. First available will be 192.168.0.1. The broadcast is going to be one less than the next network address. And the next network address is going to be 192.168.0.32. Okay. Because remember, now that you're getting more subnets, you're actually getting less IP addresses on each of those subnets. So it's going to be one less of the next network. It's going to be one for the broadcast, 192.168.0.31. And the last available will be 192.168.0.30. So as you could see, there's going to be a total of 30 addresses that I can use on each of these subnets. Okay, available that I can use. If I count total, I also have to count the network and the broadcast, which would bring you to 32 addresses for each subnet. Okay. And what we're doing is we're really looking for this target IP address, which is 0.194. Where does it lie in all of these other addresses? Right? Well, what we can do is we can have some type of a shortcut here to represent this a lot easier for us. What I can do is if I know they're going up to 32 every single time, well, subnet C's address is going to be 192.168.0.64. Okay. And if I look at subnet D, Well, it's going to go up 32 of 64. And if I add 32 plus 64, my next network address is going to be 192.168.0.96. And if I'm looking for my target is 194. Okay. So I'm going to keep on going. Okay. And by the way, if you get stuck or if you're kind of lost, all I'm doing is adding 32 to each subnet. So 96 plus 32 is my next network address. And my next network address will be 192.168.0.128. If I add 32 to 128, my next network address will be 192.168.0.160. And if I look at subnets G and H, 160 plus 32 is 192. 192.168.0.192. And 192 plus 32 is 224. So I'm going to have 192.168.0.224 as my, as my network address for subnet H. Okay. Now, if we add 32 again to 224, we eventually come to this number of 256. And IP addresses can never be 256. So if you're talking about the next network address, all right, you would actually have to change that third octet from a 0 to a 1. But since we're staying in the range of Class C networks, you're never going to see that third octet change right there. All right. So I'm not actually going to fill in all of these, but let me just go ahead and show you. I'm going to jump over to this target IP address, which is 194. Let me go ahead and bold this. If it's 192.168.0.194, all I have to do is if I want to find this subnet or where my target IP address's subnet lies, I would have to look at these network addresses and say, how far did I go up to reach 194? Well, I passed 0, I passed 32, I passed 64, I passed 96, I passed 128, I passed 160, and I get over to 192. So my target IP address is in subnet G. Okay. My first available would be 192.168.0.193. And my actual target is between, which is 194. 194 would be between 192 and 223. 192.168.0.223. And my last available will be one before the broadcast, which would be 192.168.0.192. Or I'm sorry, 222. I forgot to add the decimal there, so I'm going to add it. And here, I'm going to go ahead and say that my target IP address, which is 192.168.0.194, lies somewhere in subnet G. And it's actually after my first available. So it would actually, my target IP address would be my second available address in subnet G. It would belong to one of those IP addresses that are available. All right. And again, I won't go further and keep on adding the first and available and broadcast to each of these. But as you can see, the farther you go with CIDR notations, the more subnets you're getting, right? But the more subnets that you get, the less available addresses that you get for each of those subnets. Okay. And as long as you understand the chart of translating binary to decimal or decimal to binary, you'll be able to learn how subnetting works. All right. So I'm going to go ahead and do this. For my last magic trick, if you will. This is not magic, by the way, but for my last performance here that I'm going to do for y'all, I'm going to go ahead and run my Python script that's going to automate all of this for me. And if I said that it lies in subnet G, let's check to see if my numbers are correct. I'll go ahead and type my target as 192.168.0.194/27. So let me go here and let me go ahead and make this, see if I can change the view of this. And let me zoom in a little bit. I'm going to clear the screen and I'm going to run my Python script. And now it asks me to enter a target IP. Let me go ahead and enter the one that I was doing on my Excel spreadsheet, 192.168.0.194/27. Okay. Now let's see what the results are. It tells me that my subnet mask is 255.255.255.254. Let's go over to subnet G and let's see if that's correct. And subnet G shows me that, oh, I'm sorry. My subnet mask is 255.255.255.254. That's correct. Let's go over to subnet G. My network ID on that subnet G is 192.168.0.192. Let's check our work. And there it is, 0.192. What's our first available? 192.168.0.193. Let's check our work. Here it is, 0.193. What's the last available on subnet G? 0.222. And here's my last IP available on subnet G, 0.222. What about the broadcast? It says my broadcast should be 0.223. And there it is, 192.168.0.223. So I'm going to go ahead and stop sharing right here. And what I basically did today was show you that you can learn how to subnet if you learn how to translate binary to decimal and decimal to binary. If you know that conversion from base 10 over to base 2, you can learn how to subnet. And all you really need to know is when you're translating that CIDR notation, all you're doing is you're adding bits to your subnet mask. Okay. Okay, I'll go ahead and stop this lecture. And if you have any questions, please send me an email. Thank you for watching. I'll see you again on the next video.